Perfect. So then, hello and welcome to our deep dive about the Production Assist 14 release that we are hosting today. First, let me introduce Danny in here. Danny has started recently here at Production Assist, and his main task currently is updating our documentation, handbooks, tutorial videos, and stuff like this, so that we generate a little bit more content in there. So part of the 1.14 release in there is also to improve documentation and usability of Production Assist. So welcome to Danny. Then as a next thing in here, we will walk through the different topics that Production Assist 1.14 has. We will start with the SketchUp integration that we've been updated. There is a complete new workflow in SketchUp that allows you to snap trusses, add point loads and stuff like this, and make it way more convenient to actually use SketchUp and Production Assist together. Also, what we are showing in here is the work that we've been done with AluVision together. In there, we will show you how you can calculate AluVision boosts directly using Production Assist and SketchUp. We're hosting also a training tomorrow about this. So if you're interested in this, just look on our Instagram or Facebook and you find the links in there. It's also a free training. In this deep dive, we will show the basic functionality in here so that you know it's there. For more details, it's a good thing to actually look to join the training and look there. We'll also show Capture in here. Note that we are showing Capture 2026. So that's unfortunately is an unreleased version. We still need to wait a little bit about it. But actually, as we are releasing it, and this has already all the functionality that you need to connect it with Capture, we want to give you a glimpse on how the workflow actually is with this, what you need to expect. There will be still some improvements that will happening on Capture, so they are actively working on it, but it gives you the global picture. It's a little bit different than the other implementations that we've done for other tools, but it's quite powerful. Then we will have a look onto the AutoCAD or BricsCAD implementation that we're doing in there. There are a lot of the stability of the platforms has been updated, and also a complete new way on how to use snapping in AutoCAD or BricsCAD, as well as the tool are basically aligned with what is in SketchUp and all on the other platforms with this. After this, when we cover a little bit more the platform stuff, we will look into the detailed things in here and how to use them. And we jump a little bit between the programs that we are partnering with. So we have the error workflow that we want to talk about it. We have the roof force limit that has been added to Production Assist. There's some, wait, let me bring something in there. There's some information about the deflection limits and how we display them. There's a new feature which is called 3D load geometry, where you can basically calculate a load based on a 3D volume and distribute it across multiple trusses. We have done quite a lot of wind load improvements so that you now also can take into account the terrain category, which makes it a little bit easier and more reliable on how to do wind load calculations. Inside the Layher support, so for scaffolding, we have added a lot of new layer cross sections. We have added the proofs for spindles and how much you can spindle something out, which is quite cool. We have added the friction calculation to Production Assist on a nonlinear way, so that actually when the friction is exceeded, that you can tell Production Assist that actually the support also should fail. We have a new way of calculating the complete system. It's called delta P, or second order calculation with this. That is something that applies basically to all the calculations. It's a nonlinear calculation approach. We will show you what you need to know about this and why this is cool that we now can do this. We have the new functionality for the internal webbing calculation, and that comes with a lot of, not a lot of, but at least the starting point of new content that you can use with Production Assist to calculate tubes and bracings. And then as a last thing, we have the reporting functionality updated to use AI. We wanted to give you some information about how we approach this topic and how we actually use this in order to give you benefit without risking that the AI actually hallucinates and writes things in the report which are not true. We've made there some precaution, and we want to show you what we've been doing with this. But first, let us start with SketchUp. So we have a complete new SketchUp plugin. So quite some time has been invested into this. It's now way more user-friendly to use it. And the main thing that you will notice is that we now have a toolbar in here. There are a lot of tools that you can use in order to make Production Assist work a little bit better in SketchUp. The first tool, which is actually quite interesting, is the magnet tool in here that you can have. So if you're selecting a truss in SketchUp, activating the magnet tool and holding the Option key, you actually can snap the truss in there. And every time you're adding a truss in here, basically you can snap this around and then edit. This also works with corners. So for example, if you use this, select it to snap, you also can do something like this and really build easy, fast, and nice systems in here for the calculation. This is basically the snap functionality in here. In order for the snap functionality to work, you need to have some special blocks in here. Unfortunately, or I think in SketchUp it's called component, unfortunately this does not work out of the box with all the content which is on 3D Warehouse. There are some things that you need to modify yourself, but then you can use it. We deliver some content together with Production Assist. So if you look in the downloads now for the plugins, you always find a native library that comes with Production Assist. And for example, in here for this, there is the library that brings you all the ProLight trusses that has been prepared for the updated calculation engine and for the snapping and stuff like this. But one step after another, when you, for example, want to now calculate this in here, what you can do is you can activate the SketchUp in Production Assist. So you click on the PA with the green arrow. This will basically make Production Assist start in here and read this thing. And then if you click on the user interface in here, it will show you the user interface of Production Assist that you already know and that you also can use for modifying stuff in here. When you now, for example, go to the influence lines and show the deflection figure, you will see directly this deflection figure is also shown in SketchUp. And in addition to this, it also shows you the forces that there are in the motor. So now when you go click on the motor, which has been inserted in here, activate the move tool and move this thing. Every time you're doing this, you will see it's actually changing the forces on it and updating you the calculation engine with this. It's quite convenient to work with this. I go over some of the other tools as well with this. So for example, there is now a tool to insert point loads. So if I'm activating this, I can now select a part of the truss. You also see a snapping highlight in here. If you then click, it asks you how much pound or in kilograms you want to add in here. So we start with 150 kg, pressing OK. And you see every time you're doing this in here, it automatically also updates the calculation. The workload also can be shown in here, bending moment, all of this is integrated in here. Wait, we need to also show this in here so that we see the deflected shapes in here, all of them, that you can use it for the calculation. An important thing to notice about this is that all the results are shown by using the overlays in here. So if you click on here and hide and show the overlays, you can actually show specific entries in here. or you can click, for example, on the production assist errors, and it will show you the errors, for example, in here, that the hoist doesn't have anything assigned in here with this. And if you then select them, go in here into the structure tab and assign them a load by like 5 kilos or whatever, if I found, this error message will also go away. So that's an easy way of doing and changing these kind of things. I already noticed or mentioned our integration or cooperation with AluVision in here. So just let me give you one example in here with this. So let me open this. So in here, we do have an AluVision booth in here. And this AluVision booth has been drawn with the components that AluVision provides directly on the 3D warehouse. What we always recommend to use is the extension that they deliver. So there's an AluVision exhibit and events in here. And for example, one thing of it is that it brings you the entry point for all the AluVision components in the 3D warehouse. There are quite some components in there. All of them have been updated to work properly with Production Assist. That was quite some work. Some of you already know Patrick. So Patrick did a lot of the work. So thank you a lot to this, but also thank you to AluVision. It was quite a lot of work of actually doing this in here and bringing it into life. Now we have it. So I've already drawn a small booth in here with some LED tiles, with some things in here, and same thing. So you load this into the Production Assist in here. When you do this, it automatically asks you if you want to use the floor support. So you're pressing OK, and then it will calculate the specific booth in here and show you the results. I normally then adjust the floor level so that it's actually cutting the things. We set this to millimeters and use 40 in here. Okay, with this. And then when you do this, it actually can calculate this boost. It, for example, shows you the deflected shape in here with this. So how is this deflecting? Note this is a scaled view, so it's not deflecting this big as it's shown here, but it's showing you the scaled deflection in here. It also shows you the workload. So if it's green in here, means it's not overloaded with this. It calculates you the forces on the ground with this and how much ballast you need for this kind of calculation. It also calculates you all the different like connectors that you have in here. So if you click on this thing in here, go to truss, you see it will calculate the corner profiles in here. It will calculate the omni profiles, and it will calculate the frame element quick tighteners in here. So how much actually in here goes through the thing. Again, tomorrow there will be a complete training, which is a little more on the application of all of this in here, on how to calculate it, how to generate a report of it. But this is basically one of the new features in here that you now also can calculate the AluVision material in here, that you can use it. So basically everything that you can build with this AluVision components, we can calculate in here. That's about the SketchUp plugins as far as we want to go in. So let us start Capture here as the next thing. Again, we are using Capture 2026 with this. This is unfortunately not yet released. I think they will release in the next few months with this so that you can use it, but it gives you a good impression on what is actually possible and how it will work with this. We will start with a really, really simple file in here. So I have just a run of trusses in here that I've been doing. There is something that is acting as a support in here. And now what I can do, what is the new functionality in here? There's a send to production assist button right away in Capture. So if I'm now clicking on here, it will start production assist, so the desktop app, and will calculate it in here. So once the calculation has been done, Capture asked if you want to overtake it, and then if you click on yes, it will automatically update you the links and show you the calculation results that you have in here based on the different things in here. So you see we have 3 slings. The first one takes 220 kilos, the third one takes 62 kilos, and the first one 84. When you now start moving stuff in here so that you actually change this a little bit, Or if you even want to add more fixtures in here, so I don't know, maybe this one in here, so add some more fixtures that are available in here with this. You just can send it again to Production Assist, and then it will update you the calculation. It will show you there's new load data. You click on yes, okay, and then you see now there's the new calculation results available also in Capture with this. The way how this works is that it basically opens the app in the background, and it shows you after a calculation the calculation overview with this. So the most important part normally for the persons that are working with this is they want to see the overall state, which is the traffic light on top of here. So currently this is yellow, which means there is something at a high workload in here. So we will look at what this actually is in here as a problem. There's a table with all the loads in here. It gives you how much does each of the different fixtures weight with this. For example, there are 6 Mac Viper beams. They have a 83-pound weight. There are 6 of them, so about 500 pounds is the total weight in here. One note about the units, once I'm seeing it's a little bit mixed. So we do support the US units and we do support the metric units with this, so imperial and metric. You just can change it. Just the last calculation that I've been doing in there was an imperial system. That's why it's still showing the pounds in here. So then you have the total weight of the structure, which is 870 pounds with this, and gives you an indication in here. So how big the specific thing is. For example, in here in the hoist, it shows you the maximum value that you can have for it. That's why it's yellow, because it's over 80%. And it also shows you the workload on the different trusses in here and shows you how much they're used. So the actual workload of the truss is 8% with this, which is not a problem. You can also sort it with this. And it gives you an example on how much this is loaded. If you close this dialog, you will see that also the 3D model of Capture has been sent over to Production Assist in here, and that it will be shown like this in here. So if you now want to see the reaction forces, you just use the normal controls in here. So you're clicking on the influence lines, you're clicking on the bending moments in here, clicking on the shear forces or deflection or whatever, and it shows you the different values in here that you can use. If you then click on show workloads, also shows you the workload on the truss in here. And for example, if you want to add a new hoist in here so that it's not hanging only in 3, you go to the library, you go to built-in, you go to the, where do we have it, to the sling, and then basically just drag and drop the sling into here with this. It automatically snaps. And in order for Production Assist to recalculate it, you click again the send to Production Assist here, and it will automatically calculate this, update you the calculation. And also now you see, now there is this sling also in here inside Production Assist, updates you all the calculation things. You see this goes down, and also now you can update the calculation thing. So you've just seen it, so it goes a little bit down in here with the weight. So it's a really easy way of sending stuff back and forth with Production Assist. The cool thing that all the library elements have been updated with this. So for example, if you now look into a little bit bigger structure with this, let me open this. Oh, wait, in here, that was wrong. So let me drag and drop this around in here. Let me open this. No, I don't want to change it. I feel lucky. So for example, in here, what you have is a 3D thing in here that they have been built with Capture. Also, this can be sent to Production Assist. And if you send this to Production Assist in here, you will see this will be added into addition to this. Currently, we don't transfer the ground support attachments with this. So that is something that you would need to add by your hand. So you click on New, you click on Ground Support Attachments in here, and do one, wait, so that it snaps correctly. 1, 2, 3, and 4. And then basically it would calculate the specific thing in here, also from Capture, and give you the load combination of this kind of ground supports. Yes, great. Just let me look up my thing in there. So for the next thing, I will quickly jump to our BricsCAD thing in here. So you see the better thing of myself. And let me share on Windows. So for example, in here, when you're seeing this in here with BricsCAD, which is an AutoCAD clone that you can use, it also allows you to calculate this. And one of the new functionalities that we have is when you select a block in here, you actually see that it now has two handles, these ones. And with these handles, you can copy or you can move this thing. So if I'm using this in here and selecting it, it will automatically align to this and will snap to this specific truss so that I can connect it with it. It's a really cool feature to move stuff around. So if I want to move it back with this, I just can snap it and you see it automatically aligns and rotates this. This is also working when you have like multiple things in here with this. So if you have all of them selected, you hold the Shift key pressed, and then you will see it will automatically be able to be copied in here. So copy it like this, and then snap it to this functionality. Sometimes a little bit challenging to snap it to the right thing. So to find it, now you have it like this. When I now start copying the copy the thing, I can copy the hoist in here like this, and then there's obviously someone calling. With this, I have the new hoist in here. So now also a new functionality is that it automatically adds the production assist user interface in here. So if I'm now clicking on enable production assist, it will actually calculate the load on this. It is now also visualized in here if something is selected, and then I can also show in here with this, for example, what is the deflected shape, and same thing in here. Every time I'm moving something around with this, it automatically updates me the deflection figure, and it automatically updates me the calculation part. So now I've moved something in here, so you see that doesn't work with this. So let me quickly snap this back to this. So you see snapping is quite easy with this, that it's doing this. So now snap this to here. And now I have my consecutive truss figure in here. What we've been also added in here, for example, are tools to insert line load. So if you click on here, it asks you what should be the name of the line load. It asks you for the layer of the line load. It asks you of the total weight. So you say like 1,500 kilograms, pressing OK. And then you can say the start point should be here, the end point should be here. And if you're done adding this, it automatically adds you this line load in here. And basically what you're seeing, because there's so much load in here, it basically lifts the other thing to the side. The results in BricsCAD are also shown in here. So if you go to the workload, basically you see this is now overloaded at this place. A little bit later, we will look on the error replacing workflow with this. So it tells you, hey, a good thing would be now replace this with an H30V, this H30V truss with an H40V truss. So that's actually a quite good thing to do it. We also have other functionality built in here, so that they all are the same. So these functionalities are also available in SketchUp. So for example, there's a select system menu command. So if you activate this, you can select the first truss in something. If you do that, it will automatically select everything which is part of this specific truss system to move it around. There's something to stack trusses. There's something to insert drops. So basically all the functionality that you have for modifying this kind of symbols now have been also added as a menu command, so that it's quite easy to change this. Let me delete the line load. For example, if you want to do an area load, you now can also do this. So you define how the area load should be in here with this. We do it like this. I can close it like this. The block name should be area load, should be 575 kilos. Okay, enter. And then it automatically generates me this thing, and you will see it will automatically update in here the calculations so that now the new load is in here. If you, for example, activate the shear force, you actually see the different shear force elements in here that are applied for this, where the load of this area load will be inserted with this. Okay, that was the glimpse. What have been started with BricsCAD, And as a next thing, we will actually jump into our error workflow. For this, we will have a look on Vectorworks for this, because it's quite easy to show this. And I think everybody knows this thing when you work in big drawings where a lot of people work, is that there are quite a lot of error messages, and it's quite easy to generate these error messages in here. So what we've been added for this release is that there is a fix button. So if the error message that you have has this prependix fix, you basically just double click the error, and then you see it moves to this so that it can fix it. So in here, we assume that this needs to move to this truss. And when you do this in here, it will automatically fix it like this. At any point, you can move it back or use the undo functionality to go back in here. That's why it's a click-based thing in here. But basically, every time you're double-clicking on the error, it will just double fix this, and then the calculation will update. One thing that was already in the last version of Production Assist is the actual error workflow with this. So the new thing is really the double-clicking. Already before, we had this option in here that allowed you to fix specific errors based on this on the suggestions in here. There's something that we call base confidence level. So how sure are we that actually this fix is a good fix and we know what we're doing? For example, in here for this thing, we don't really know if this actually is fixing it, because this load can be assigned to this and this. So that's why by default it is not in the fix all errors above confidence level. If we set down the confidence level to like 10% with this, you will see all of these things will be turned green, which means that it can apply the autofix. And if you're then clicking on this button in here, it will automatically move all the fixes and give you the calculation for this. So if you have a drawing with really a lot of errors, that's a really easy workflow to fix things, and it will automatically make this work directly so that the production assist can calculate it without the need to do everything manually, and there's always a suggestion what should be done. So that's actually a quite nice thing in here to work with this functionality. Again, all of these actions are undoable, so basically we just only move the specific things. It's also available in all the other plugins and desktop applications that we support. So it's one way of doing the thing in here. The next thing that we have in here is the roof force limit. For this, I've also prepared a small file in here. So where do we have it in here? Roof. So often when you have calculations on a roof system in here, you have something like a roof system, and there is a specific capacity based on the individual beams in here. So for example, there's one main beam and there is several spreader beams in here. And they do have different load capacity based on the load that is applied to the beam. In Production Assist, we now have a feature to actually allow you to calculate the specific things in here and define for a specific beam a maximum resistance in here. So for this, you will need to use the line workflow. It can be assigned to all the structured geometries, but with the line workflow, it's normally the best. So just as a remember thing, if you click on Files, on Settings, there is a really specific way on how to set up the structural lines that basically tells how to read specific line-based geometries like lines, polylines, or 3D polylines and assign them to a specific cross-section. If you look into this, what I'm showing in here, you see that I already created everything. So you have a roof class and you have a layer support class. So the roof class is mapped to the internal connection thing in here so that it's not generating a workload by default. And I have added some points on the class layer support, which will be used as the supporting points to the roof. So now in order for Production Assist to get access to these things, we need to select all of them, go to Modify, and there is Create Symbol. We call this Roof. And then if I'm pressing OK in here, or I already created this roof block with this, I'm pressing OK. OK, and now Production Assist is able to see this as a structure. And if you now go into the 3D view, for example, in here, you will see that it can calculate this now. Well, it will not calculate it right now because there is no loads. So as a next thing, what we do is, for example, we add some loads in here. So I add one load directly in here. And then you see automatically this will be used for the calculation for this specific thing. If I'm now showing the workload in here, you will see still everything is gray with this. So it's not calculating a workload. So there's one step missing, and that is basically the magic in here with this. So in order to set for each of these individual beams the right amount of force that it can take, you need to select the symbol. You need to go on Edit and click on the button Edit Defining Resource. If you're doing this, it basically jumps into the symbol, and then you just select the structure geometries in here. Basically, I'm selecting all of them so that I have all of these structures selected. I open the structure tab, and then there is a max force, max total force on beam. I quickly set this to kilonewton. You also can set it to kilograms. For example, you can say the maximum force on one beam should be 500 kilos. Pressing OK, save and close will now actually show you the calculation for this. And now it becomes green because now it can check that in here, basically the 50 kilo is below of this thing. If you're now opening the overview of the loads in here with this, you can go to Truss, you can open this, and then when opening this, you see there is a value that you have in here and how much of this has been already been used. And then, for example, if you now add also a load in here with this, you will see now it will increase a little bit with this on the side. Now, if you increase this a little bit more, we don't want to the pounds, want the kilos. We go to like 200 pounds. You see at some point it will change the display of this and the way how the loads on this are calculated and give you an indication on how much load on each individual beam is used and how much capacity is used. Normally, the way how you do is you set this up once so that you have a specific drawing in the background, and then you can just import it into other drawings so that you can use this specific functionality to limit the roof capacity, for example, for other ground supports that you can use. Okay. Let's step into the next thing. This is not a, well, it's always hard, not, oh boy, I did a mistake in here, but that doesn't really make a difference in here, is the display of deflection limits. By default, when you're inserting a truss in here, they don't have deflection limits. So for example, if you have an European truss, I make this extra long with this, and I do add some fixtures, some hoists in here, you will see that the workload of the truss is actually 23%. So it's totally been doable to have such a long span. If you now show the deflection relation in here and activate this, by default, if it's a European cross-section, it will become gray. This is basically the workload based on the allowable deflection. You can set the allowable deflection inside the load combination settings. And there is a button in there which says limit deflection. So if you're activating this, pressing OK in here, it will automatically calculate how much is this deflecting and if is this deflection in an acceptable state. So if you activate the deflection limit in here and you, for example, click on show combined deflection, you see there is a maximum deflection that this can have. This is a light blue line and a dark blue line, which is the actual deflection in here. Note that these deflection limits in the European unit are based on specific applications. And the load tables that the truss manufacturers prepare do not include them. So depending on the load case, the allowable deflection is different. This put a lot of pressure on the American truss manufacturers because by default, American trusses actually do use the deflection limit. So if I'm using some American truss in here, so where we have something in here, for example, Tyler 12 by 12, where's the AB truss? Let's use 12 feet. And enter them. So 1, 2, 3, 4, 5. Hoist, enter them in here. Let me quickly disable the deflection limit so that we don't have this. So if you now go into here and click on the deflection limit, even if we don't have one, this already has a deflection limit built in. So US trusses are rated by L180s or L160s, depending on the choice of the manufacturer, based on how much they are allowed to deflect in here. So the change that we have with this is that the deflection limit is now basically showing you the deflection limit. Before, it was just coloring the biggest deflection red and all the other deflections accordingly, which led to a lot of confusion, to be honest. So that's why we did this change. As it's something with the results, we wanted to be transparent and show you this, what to expect and what is happening with this. Okay, next feature, we also showed us in Vectorworks. It's actually a quite cool feature. It's 3D geometry loads with this. We already have point loads, we have line loads, we have area loads, we have free line loads. But what was missing were basically loads that represented 3D geometries. So if you had a 3D geometry, how does the load distribute between these two things? So you see it's really like flexible with this. It's a little bit challenging with this. It's only on 2 pings, maybe a little bit easier to do this, to calculate it. But you now can create a 3D volume thing and then import this as a symbol into Production Assist. And in the special loads behavior of Production Assist, there's this use as 3D load. And this will automatically do a 3D load analysis on this. The trusses will be used as a support, so it needs to be close to a truss in order to be supported in there. And then every time you're moving this thing around, it will basically calculate this in the background. I've set the force unit to kilogram, that's why it's now showing you this in kilograms. It's 500 kilos in total, so every time I'm moving it, it basically checks how the load will be calculated with this. The cool thing, this applies to all different kind of load figures. So also if you have like wood constructions which are like scenic curve with this, you can turn them real easy into a 3D load by just importing them into Production Assist when you convert it to a symbol in production in Vectorworks, and then click on the use as a 3D load. So for example, the users that have requested this, they're using this to calculate LED walls that are placed on this and calculated with this. Perfect. So with big steps that we basically have enough time with this, let me close this real quick and open the wind load things that we have in here. So yes, you already see this. So this structure is basically coming out of our engineering office with this. So it was one example. We chosen this because it's actually quite interesting, because depending on the terrain category, this structure will fail or will not fail with this. So that was a good thing to show you the importance of what we're doing. So this structure is set up so that these elements in here are wind load planes. If you click on them, you can click on the structural tab and now on the wind load tab, and you see they have been activated to use as a wind load plane. There were a lot of questions about this. So when to use as wind load plane, when to use as a structure, and when to use as a wind load geometry. We added some images in here. So if you activate the use as wind load plane, the actual polygon in here will used as a wall. And then depending on the shape, different wind approaches will be applied to it. So for example, in here, because the structure is so high and doesn't have so much width, the actual wind load that will be applied is based on the high with this. So there's a specific like setting on how to do it, and then it will be applied like this. On the same thing, there is a dialog for the bigger structure in here. And you see, because the width is way bigger, this basically independent of the height of the structure will always get on the full area the complete maximum wind load with this. So this was one of the changes that we've been doing. So if you use the wind load plane, basically they will act as a wall and it will use the right wind load depending on the aspect ratio of the different shape in here. This is calculated automatically. What we've been also adding in here, if you click on the load combination, is some short handles that allow you to change the calculation settings quite easy. You can change it right here in the load combinations. If you click on the load combination settings and open the wind load settings, you basically see that there are some pictures with this and sometimes easier. So this structure was in the Netherlands. It was in Amsterdam, which is wind load zone 2. And now it becomes interesting. It is in the terrain category 3. The terrain category 3 is light city. And that is the top image in here, which basically shows you how the surrounding terrain will look like. There are, so this is also based on the location in here, 3 other terrain categories for the Netherlands. One is 2 for rural areas. So if you're selecting this, it will change this to be in rural areas like this. So if there's like fields and this and no tall buildings. If you now press on OK, the workload was before 91% and now it's 94%. Then as last, there's the O terrain category, which is the C. And then if you change this to the C, you will see now it's actually overloaded and it even starts to be tipping. So depending on the terrain category, this structure fails and changes. These terrain categories, wait, this was the wrong button. These terrain categories basically define at which height, which wind pressure is shown. So right now it's set it to be light city. That means that the wind pressure is increasing at 7 meters. If you set it to the rural areas, the wind area will already increase at 4 meters. And if you set it up to be at the sea, you will see starting at 1 meter, it automatically increases the wind pressure in here. This is based on the Eurocode in here, so that's all this mess has already been done for you. We've been added some new countries in here. So we now have Belgium and Italy in here. So if you, for example, click on Belgium, they don't have the wind load setting 1, 2, 3, but they have like based it on the wind speed. So 23 meters per second, 24 meters per second, and 25. And you see they also have slightly different terrain categories in here that you can use. We also aligned this. So for example, if you click on France, you will see there's also different ones in here that are used. Basically based on this, there's always an image with this. So if you click on countries, if you click on countryside in here, then city, it shows you how does this look like? What is the actual relevant change in here? So that you can use this for the calculation in here. Let's jump to the layer improvements with this. So I click on stop sharing, and for this, we will move to the other computer again with this. So going in here. For this, we have also added a default thing in here. So if I'm opening this, We have in here a scaffold that can be calculated with Production Assist in here. This is built using the complete library that comes with Production Assist. And what we now do with this, in order to do it, I enable it for Production Assist so that we can calculate it for the specific things. You see, I already did in here that the deflection figure is shown, so it's already calculating it in here. And I start the desktop app to connect it with the user interface in here. Is when you now go into this, click on here. We don't want to see this. Thank you. Plugin. You go in here with cancel. Okay. You will see now that this is also calculated in here with this, with all the different layer structures. And I need to move a little bit this the zoom things in here. For example, if you now click on the workload with this, it will automatically show you the workload on each and the individual pieces. So if you click on the overview of this, basically all the different cross sections that you can have in such a layer thing in there are in there and can be used for the calculation. The interesting part, which is really new, is that by default, now it's automatically calculating you the maximum force on the spindle and how much you can spindle it out. So if you click on here, you will see that the current spindle length is 6.7 and the maximum spindle length that you can use at this position is 37 centimeters. Note that this is currently not having any horizontal force for this. So if you now go into here and select, for example, all the things and tell them that these should get wind load by where we have it, structure, use structure as a wind load plane, wind load, use structure as a wind load plane. This will automatically now calculate the structure based on the wind load that these elements generate. You will see it becomes red, so it's overloaded in here. Well, there are no diagonals and nothing in there. So the diagonals are missing, so they would need to be entered so that this is actually acceptable. But the thing that I want to show you in here is when you now go into the spindle length, you see the current spindle length is 6.7, but the maximum allowable spindle length at this position is now 12 centimeters. Before it was 37 centimeters. You also can generate this into the report. So if I now go to File, if I click to create calculation report, and I'm just exporting the ground supports for the sake of simplicity in here. Okay, so save it on the desktop report, save it. It's generating it. Perfect. We only said that we want the list. You will get a list with this that gives you the current spindle length and the maximum spindle length. You see, it really does the calculation for all of these different things. So there are some that basically are unchanged and some where there is a 16 centimeter limit now in here, or even 11.5 kilonewton meter spindle. This is always because the horizontal force and the vertical force are applied to the spindle in here and gives you basically the amount on how much this is in here. Once we are in here, we also slightly change the way how we export the tables in the FEMA appendix so that it's not that long anymore. So we doubled this specific table in here so that you have the notes a little bit easier. And it's a little bit easier to read all of these things in here, and it's not taking this much space in here. So just change back in here with this to have the next things and to go back. Yes. So the next thing in here is a new calculation system that we have, and it's called second order analysis. And in order to show you what does this bring to the table for you, let me open a specific sample file and have a specific mass next to it. So before in Production Assist, at least for the users, it was not possible to calculate using the second order approach with this. And what is the second order approach? So when you're doing a structural calculation, by default, you are calculating the forces and the reaction forces, shear forces, moments based on the undeformed shape. So effects like that this actually bends a little bit to the side does not have effects on the forces that will be calculated. In other words, if you have a column which gets a normal force and a horizontal force, the resulting bending moment on the column would be constant. So it does not take into account that actually there is a deflection to the side. What we've been now have added in Production Assist is that we also take into the account that the truss basically moves a little bit to the side. So this is now on the right side of this. You see there's a normal force which has some deflection to the side. And now the bending moment that is the maximum is consistent out of the horizontal force like before, but also the eccentricity, so the delta in here has an impact. In Production Assist, you can activate this by just clicking on the second order calculation in here. And if you're doing this, you will see now the actual bending moment looks a little bit different in here. So this is because now it actually, actually takes into account the deflection. This is something that is called a non-linear calculation. So typically, a property of the first order calculation is that it's linear. So if you double the force, the actual resulting deflection will be also doubled. In the second order calculation, this is not true. So if you double the force, you need a complete new calculation because the deflection also have an impact on the forces with this. So it actually uses a little bit a different math in here. We've noted this to the bottom in here. So on the second or and the first degree calculation, the deflection is based on the bending moment, while on the second theory, the calculation, the deflection is based on the bending moment and of the deflection with the force in here, which is way more challenging to solve this equation. Don't worry, we did the math for you, but this basically allows you to calculate it more accurately. So typically now the question comes is, what does this do for me? So the reason why we've been adding this is that we have a lot of functionality where actually now buckling is a problem. And buckling basically is a stability problem which can be defined by the second order calculation with this. So if something is buckling, you will see this in the calculation. Like I said, so in the first order calculation, the deflection is always linear. So the more load you apply, the more you get. Why? While in the second order calculation, it's not linear. And in there you see the buckling effects. So typically this is will not make any difference for you as long as there's no normal forces on the trusses. But if there are normal forces on the trusses, this actually will change the calculation results slightly. By default, this is turned on because this is always on the safe side with this. But what you need to know, sometimes if a structure, for example, is buckling or failing, the second order calculation will not succeed because the deflection is too big and therefore the calculation is not converting at a specific level. In this case, basically what you need to do is click on the load combination settings in here, click on second order calculation, delta P approach, disable this again, and then it will fall back to the first order calculation, is doing this calculation in here. And this normally, as the deflection is now linear, shows you where the problem is, how to fix it, and then rerun it with the second order calculation. So we always, from now on, recommend to do second order analysis to be really sure that all the effects that need to be considered are automatically considered in here. This is especially important for the next functionality that I'm going to show, which is the internal webbing calculation. And this is also on the other computer. So going back and forth with this, it's always a thing. So I go to the snap view in here. And if we go into this thing in here, we basically see that the calculation of this specific thing in here is based on, let me quickly disable the show structure. Let me move this to the side so it's a little bit shown better. It's shown like this. That it's basically shown based on one single line. So the beam in here basically is simplified so that the truss will be basically just represented by one line. We now have the option to also calculate all the different internal things in here. So let me make this a little bit easier to see with this. So if you click on here on the load combination settings, you can click on the button calculate internal webbing. If you activate this functionality in here, it will actually calculate the truss in such a way that it will calculate each bracing and each tube member in here. Why are we doing this? Because it allows you to do a more precise analysis of specific effects in here. So for example, it actually can give you a direct approach or a really realistic approach on how much the corners are loaded. What it also allows you to do in here is to calculate diamond trusses. So if you hang a truss, not like this, but square, you would also see the effects of this in here with the calculation. So it's really easy to do now these calculations in here. How it is doing it, it's just using, when you click on the workload, the tubes and bracings in here that are defined in our blocks with this. So in here, it gives you the idea on how much this is loaded. And for example, an interesting thing in here that we can show is, so if I'm adding a point load in here to this side, which is like 500 kilos, okay, place it in here, you will see, wait, let me quickly, now it's failing. As you see in here, a second order fail. So let me go back to the first order in here. You will see that now the calculation, it's bending a little bit to the side and that it's increasing the workload in here. So all of these kind of effects in here can be used to calculate these kind of things and have the effect on this. All the blocks that we deliver in the production assist library. So if you go to downloads, for example, in here there's a production assist library, are already prepared with this. So we are adding more and more in here so that you directly can use the things in here in order to come to more accurate calculation of the trusses. Especially if you hang it non-purely horizontal or if you're using a lot of corners, this is really helpful to do the calculation in here. What this also can do is that you can define on how the sling method is attached. So currently, when I'm clicking on the hoist in here, this is set up to go to the roof geometry to use a single tube. You can also set it up to use a bar in here, and then it actually uses a bar between these two things and slightly changes the calculation in here. So the effect on how you sling the truss actually now can be calculating using this feature in here. Oh, stop. I need to click on the stop sharing button. So now 1 hour has passed, a lot of talking. We go back to the last part in here, and then we are ready for the Q&A session. So we have updated the way how you export structural reports in here, or at least how you can do it. So by default, if you're using, so that's a really simple system that looks like this. So nothing really grave in here with this, but just a simple rig in here. So if you click on File and if you click on Create Calculation Report in here, yes, perfect, like this, it will open this dialog. And there's a simple export. The simple export, basically, when you do this, you have no impact on what text gets written. If you go to the advanced report, you now have this shown a little bit differently. And in here, there is the AI report writer. And the cool thing about this is when I now go in here, I can click and I said, I want to write a report. It asks me on what kind of system I have this and gives me the feedback in here. So the first thing is, who is the client for this project? So I say, hey, one, this should be Dearsoft. And then two, the project name should be Deep Dive 1.4. So I'm sending it. So then as a next thing, the AI thinks about it. Where's the location of the project? So this is Berlin, Germany. The structure is indoor. It's a hanging structure. And I need a brief description. It is a simple truss rig, 25 meters by 13 meters hanging in hoists. So when I'm now click on send, it will process this and has some others. So the author should be Dearsoft. 3, yes, this is good. And 1, it should be German, but not in a trade show floor. So if I'm now clicking on send, hopefully now he got everything in there. Yes, perfect. And now it starts to write in my report with this. So the way how this works now, while we look how it's written, is that basically the AI doesn't really get access to the calculation engine. So the only thing that it gets is the results and all the information that we've given and a lot of like sample documents on how to write structural reports with this. So the good thing about this is that the AI cannot hallucinate about the results that we've been giving. So it only writes you the text with this and defines you on how this is shown in here. So once we have the example in here with this, I just can move up and say update report. Then when you see it automatically generates you a preview of this report, how it looks like with the images in here and with the different things in here, how it would look like. So in here with this report in here, some of this is still marked yellow. So in here, for example, the author name, it's still something that it doesn't know. So I need to go in here and type in Moritz Staffel with this. And then I can move over with this, how it's writing all of this and giving me the different things with this in here. Automatically adds the images that I've already been created in here, adds me the chain shortening effect with this. So in the end, I just press on OK with this and save it on the desktop in here with this. And it generates me then the calculation report for this. So, and all of this has been written by the AI. But the cool thing is, for example, this table, all of them are still prepared the old-fashioned way. So what this takes away from you is always the writing the challenging text about this so that you can focus on actually generating the safe structure with this. So far, this is our deep dive with the functionality. I would now open this to the Q&A session with this. Perfect.
So yeah, one question from the chat or in general, is there an SCAD re-event plugin available? Is it the BricsCAD plugin or another one?
Yes. So the
I wasn't
SCAD
sure.
Perfect. The SCAD re-event is basically just a plugin for BricsCAD and works the same way. So all the blocks that you have in here are already also prepared to work with SCAD. So it doesn't really make a difference if you work in SCAD or if you have just a normal BricsCAD with this. It is supported. So it's using the same snapping definitions. It's using the same weight systems with this. So that is just working. We will add more and more of these trusses in here so that you can use it. A lot of the SCAD library also have been updated. The important thing so that Production Assist can read it is basically that you have a specific, wait, let me hide this, that you add, let me quickly hide this, is that you add the middle lines on a specific layer in here. I know that also SCAD has been updated some of their content with this. I don't think they've done everything with now, but step by step we will adding this so that you have this as well in here so that you can use it. So as long as it has the truss center static line with the right cross-section assigned, you will be able to calculate it out of the box. Also, the layer library that you have included in Production Assist in here in the scaffolding thing is designed to work with SCAD so that you can draw your layer tables with this. So, Danny, is there another question?
No, the rest is sorted out, I think.
Perfect. Are there any other questions? No, perfect. That was then a good session. Thank you so much for your time and your interest in Production Assist. If you need more help with this, just book another appointment over our webpage so that we can help you and have a look on your project with this. And then thank you so much for your time and talk to you later. Bye-bye.
Bye. Bye-bye from my side.
Thank you very much. Bye-bye.